So in our last class, we have discussed about what is the process of equalizer or what is equalization, the definition of an equalizer, why equalizer is used in wireless propagation or wireless communication, and how equalizer is used to overcome the effect of multi-channel, multipath effect in the wireless propagation channel. We have also gone through the different types of equalizers, broadly classified as linear equalizer and non-linear equalizer. Okay. In linear equalizer, we were starting with the zero forcing equalizers, one of the classification of your linear equalizer. And with respect to the equalizer characteristics, we have also studied the major practical limitation of an equalizer, which is the noise enhancement during this wireless propagation of radio signals. Okay, how equalizer minimizes ISI, but in certain scenarios, it is also causing an enhancement of noise which is present in the signal in the propagation, while in the wireless propagation mechanism. Okay, so we have classified what do we mean by actually noise. Noise is nothing but any kind of unwanted signal which is present in your received signal. So if I want to receive a desired signal and if any other unwanted signal is present along with my desired signal, that signal is termed as simply as noise in the propagation channel. Okay, so we have gone through 3 parameters. Now today we are going to start with a brief introduction of again zero forcing equalizer. Then once we finish this, we will be discussing about the other type of linear equalizer, which is MMSE equalizers, and then the final one, which is your adaptive equalizer for linear equalization. So these 3 are your different types of linear equalizers which are there in your syllabus. So starting with what is zero forcing equalizer. In my previous class, we have introduced zero forcing equalizers. In terms of zero forcing equalizers are very much used to remove strong ISI. Strong ISI means when we are facing strong fading. So the symbol interference is because of multipath effect. Now this multipath effect can be having the types of fading. Fading means there would be variation in the signal amplitude and phase which we are receiving at the receiver side. Now, when do we have strong fading? We have strong fading when the delay spread or the amount of delay introduced by this wireless propagation channel is very, very high. So when this amount of delay is very, very high because of multipath effect, then what is the implication on the type of fading? So when this becomes very, very high, the coherence bandwidth of the channel reduces. So what is coherence bandwidth? The range of frequencies over which the channel remains unchanged. So when this range of frequency is reducing, and if this reduces, that means it becomes less than the signal bandwidth that we are transmitting. Okay. So when the coherence bandwidth reduces or it becomes much smaller compared to your signal bandwidth, then what happens? The channel becomes or channel variation increases with respect to your frequency, and you experience certain thing which is called frequency selective fading. Now, when does this deep fading happens? This deep fading happens or strong fading happens when we have destructive interference experienced at the receiver side. So at the receiver, you will have multiple copies of the same transmitted signals, which are delayed version of the transmitted signal. Now, due to this delay, some component will have different amplitude, difference in amplitude, some component will have difference in phase, and when you are doing summation of all in something which is called destructive interference. So what is destructive interference? Destructive interference means that the phase of the received components when we are doing summation. So if we see the phase is exactly 180 degree or nearly equal to 180 degree or pi. Okay. So when the phase is nearly equal to 180 degree or pi, then we experience that the signal cancel each other. Happens the result that means there is fluctuation in the phase of there is fluctuation in the amplitude of the signal, fast fluctuation in the amplitude of the signal with respect to time. So this happens when the phase variation is almost equal to pi or 180 degree. Then we experience something which is called destructive interference. So signal amplitude becomes strongly affected because of destructive interference, and we lose some part of the signal when it is transmitted through the wireless propagation channel. So at the receiver, instead of receiving a transmitting, suppose I'm transmitting a signal 1 in the transmitter side, but at the receiver side, because of this strong fading effect, we may receive, due to destructive interference, we will receive certain thing which will be interpreted as a symbol 0. So I'm transmitting a symbol 1, but I'm receiving a symbol 0, which is not my desired signal that is being transmitted. Okay, so this loss of symbol or loss of data during this wireless propagation channel in this communication, this is actually the effect of fading or strong fading, and this effect is mostly because of multipath effect, and this multipath effect that causes the effect which is called intersymbol interference. Now this zero forcing equalizer, it tries to remove this strong intersymbol interference or strong fading at the receiver side. How will it remove this? So let us say, when I'm saying destructive interference, so the power level is reducing to 0. So now if I want to overcome the strong interference, then what should I do? I should increase the power of this received signals. I increase the level of this symbol such that instead of getting 0 value, I would something as 0.7 or maybe 0.9. That means this value can be interpreted as your symbol 1. Okay, so instead of getting an amplitude value of 0 or negligible amplitude value, the zero forcing equalizer will try to enhance the amplitude or the power of the received signal, which is experiencing destructive interference. So the power is very, very low at the received signal. It is almost negligible. So this equalizer will force the power level to increase that the power level can reach a threshold value, and this value can be interpreted as the symbol 1. So what am I doing here with the zero forcing equalizer? I'm trying to recover my symbol which is lost during this wireless communication due to multipath effect. So the symbol is nothing but your symbol 1. So let me change the ink color. Okay. So I'm transmitting symbol which is my desired 1. But due to the multipath effect, due to strong interference, we are experiencing the signal at the receiver side. The amplitude is very, very low, and this is interpreted as absence of the signal, which is interpreted as symbol 0 or data 0. But I'm transmitting 1 instead of 0. So this is wrong interpretation. So data is lost here. So the equalizer will try to regain or will try to regenerate the actual transmitted signal from this interference which is experienced at the receiver. How will it regain this? It will try to improve or force to increase the power level of this interference of the signal that is experiencing interference at the receiver side, such that the power level will be enhanced to a value which is almost of the threshold value, such that we can interpret this value as the symbol 1. So instead of now representing value as symbol 0, I will be able to recover my symbol, which is your symbol 1. Okay. So this is how zero forcing equalizer will force the amplitude of the signal which is experiencing strong interference. It will force the amplitude and it will boost the amplitude of the signal such that we can regenerate the actual transmitted signal and we can recover the lost symbol. So we are trying to overcome the effect of strong intersymbol interference due to multipath effect. Okay, so what should be the nature of the equalizer with respect to your channel characteristics? So the most important equation for this zero forcing equalizer is this equation. What is this equation? This equation relates the characteristics of the channel with the characteristics of the equalizer such that we can overcome this strong ISI. How? So the equation is nothing but the product of the characteristics of the channel with the product of the characteristics of the equalizer such that both of them is equal to 1 or a constant value. Now, why is this being taken into consideration, or how this is actually working out to overcome the strong interference? So what have I explained here is due to the channel effect. So due to the channel effect, we are facing that multipath effect. 1 is represented as 0 at the receiver side. So here my data is being lost completely because of the channel effect. So what will equalizer do? Equalizer from this 0 signal, it is trying to recreate the actual symbol, which is 1. How it is recreating? By boosting the signal such that it can be represented instead of 0 as 1. So what is equalizer doing? Equalizer is negating the effect of the channel. Negating means it is acting as an inverse of channel characteristics. Inverse means just the reverse characteristics. Just the reverse means if the channel is causing 1 to be represented as 0, equalizer will try to reverse this operation. Reverse means from the 0, it will try to recreate a 1, the actual data. So what it is doing, it is actually acting as an inverse to the characteristics of the channel. So this equation 1 and equation 2, both are very, very important for your zero forcing equalizer. So this is the guiding principle or working principle of the zero forcing equalizer. So zero forcing equalizer will always try, it is an equalizer which has characteristics just the inverse of the channel. Inverse means 1 by the channel characteristics HCF. Okay. So this is very, very important property of zero forcing equalizer. Using this characteristics, the zero forcing equalizer will boost the signal that is received at the receiver side such that the symbol which is lost here due to this channel effect of strong interference can be recovered back. So we are regenerating this actual symbol, that is a 1, by boosting up the signal which is lost during disruptive interference. How? By using inverse characteristic of that of the channel at the equalizer part or block. Okay. So this is the basic understanding of your equalizer, how zero forcing equalizer is helpful in overcoming strong interference. Now this zero forcing equalizer is actually a linear equalizer. Linear means it is a linear equalizer. So linear means it is having multiplying certain, we will find that it will multiply constant weights or constant coefficients with the received signal, and it will try to improve the amplitude of the received signal at the receiver side such that this interference can be overcome. So how we are going to do that? We are going to observe here. So in this, I have discussed this previously also, but we are just going to go through this again. So in the frequency domain characteristics, this is my received signal at the receiver. So at the receiver, my received signal y of f. Now this is in frequency domain. Y of f constitutes of three factors here. So the first parameter here, or the first factor, is the multiplication of the channel characteristics with the actual transmitted signal. So x of f here is nothing but by actual transmitted signal or symbol. So we are mostly focusing on digital communication. So we are transmitting symbols, data symbols here. Okay, symbols means we are transmitting a digital data 1 or a digital data 0. Clear? So first component of your receiver is multiplication component, which is having some portion of your channel characteristics multiplied with the actual transmitted signal. Along with this, we have one more factor, which is your noise factor. So noise is actually introduced in the channel, not because of the channel characteristics, but any signal which is unwanted, which is not desired at the receiver side. That signal can be combined with your actual propagating signal and can reach your receiver side. So this signal can be any unwanted signal which is acting as the noise. Okay. Now, if I want to use a zero forcing equalizer, then what would be the output of the zero forcing equalizer? The output of the zero forcing equalizer is actually given by this equation. This equation is generating a regenerated output. Now you see here, actual transmitted signal is being indicated as x of f, and the regenerated output from the equalizer is also indicated by x of f, but the only difference is we are keeping one cap here. So this indicates that this is the output of the equalizer. So our goal is to generate the output at the equalizer, which is almost same as your transmitted signal. So this x cap f should be almost same as x of f. This is my objective. That means if I'm transmitting a data 1, then the output of the equalizer should also be data 1 here. Okay. So that is why I'm saying it is almost equal to the transmitted signal. Now, how this output is being generated with the help of a zero forcing equalizer? The output equation is nothing but the multiplication of the equalizer characteristics with the total received signal. So what is the total received signal? This is my total received signal. I will simply multiply this received signal with the characteristics of the equalizer. Now, in my previous equation, I have already discussed here that the characteristics of the equalizer is nothing but the inverse of the channel characteristics. So in this equation, you will simply substitute that the characteristic of equalizer as 1 by the channel characteristics. And instead of YF, we are going to substitute this value here directly in the equation. Okay. So if I now solve this equation, you will find that the output of the equalizer, which is nothing but x cap f, that is almost a regenerated signal at the receiver side, the output of the equalizer. That is equal to your actual transmitted signal. Why? Because this channel characteristics and this cancel each other. So this is your actual transmitted signal at the receiver side at the output of your equalizer. Along with this, you are having one factor, constant factor, which is nothing but noise divided by your channel characteristics that is present here. So now what we are trying to do, we are trying to boost the effect of, we are trying to negate the effect of the channel characteristics. That means I want to make the effect of channel characteristics as low as possible so that my output signal can be regenerated. So here, the objective of the zero forcing equalizer is to make the channel characteristics go as low as possible. So it is to minimize the effect of the channel so that I can minimize the ISI or the intent symbol interference because of the channel. Okay, this is my objective here using the zero forcing equalizer. But now what is happening here? If I reduce this value of HCF, the factor that is multiplied with the noise, that is 1 by HCF. this factor, it automatically increases and it becomes very, very large. So if this becomes very, very large, we are multiplying this factor with the noise component n of f. So that means that the overall noise part, that means noise multiplied by the constant factor HCF. This becomes very, very, very large in your amplitude compared to your actual desired signal. So what is happening? The zero forcing equalizer is trying to overcome the effect of the channel of which is causing strong ISI by boosting the signal and reducing the channel characteristics. So it is able to regenerate the actual signal, but in this process, what is it doing? It is actually enhancing the noise characteristics. So what is happening? The noise becomes very, very large compared to my desired signal x of f. So when noise increases, it actually overlaps or it actually overshadows the transmitted signal. So now receiver has an additional challenge that it needs to remove this noise part and extract only the transmitted signal at the receiver side. So now the challenge at the receiver is receiver has already overcome this intersymbol interference successfully. So it is able to get the desired signal at the receiver. Now the major problem is it is unable to, so it has already increased the noise at the receiver side. So it needs to overcome this also in order to regenerate the actual transmitted signal at the receiver side. So this is an additional challenge and the primary limitation of the zero forcing equalizer. So in this case, the signal is recovered, yes, but we are having noise factor also amplified excessively at the receiver side. Okay. So the advantage is it is able to overcome the ISI effect. Okay. But provided the signal that the channel is noiseless. Channel noiseless means what? Means that there is no other unwanted signal present in the channel when the signal is passing through this wireless propagation channel. So when there is no unwanted signal added, zero forcing equalizer is the best equalizer possible. So this is your main condition here, that if the channel is noiseless, then this is the best equalizer possible. But if the channel is having noise, then what is happening? It is enhancing the noise factor compared to your desired signal. This makes it more challenging at the receiver side to extract the desired signal by removing the enhanced noise, that is the after effect of the removal of ISI. Okay. So this is what is the main linear equalizer that is there in your syllabus, and this is the basic understanding of zero forcing equalizer. So zero forcing equalizer is most effective for removing ISI during deep fading or destructive interference or strong fading scenarios only when noise in the channel is negligible or there is no noise in the channel. But if there is noise in the channel, then the noise will be enhanced compared to your desired signal, and it becomes a practical limitation of zero forcing equalizer. So this is your first type of linear equalizer which is there in your syllabus. Okay. Next one is your MMSE equalizer, which is another category of linear equalizer, which is part of your which overcomes the limitation of your zero forcing equalizer. What is the full form of MMSE equalizer? It is nothing but minimum mean square error equalizer. So here, instead of just finding out the difference between the received signal and the actual transmitted signal, so what is the error actually? Error here indicates the difference. So I am transmitting, suppose, a signal which is a symbol 1. But at the receiver side, I am receiving a symbol which is 0. Okay. So I'm transmitting 1, but I'm receiving a 0. So for MMSE equalizers, we are focused on first calculating what is the error between the received signal at the receiver side with the desired signal or the transmitted signal from the transmitter end. So the difference between the two is your error signal here. So this error is actually calculated. So this is your formula here for calculating the transmitted. So to calculate the error between the received signal and the actual transmitted signal. So what is the difference? The difference is the transmitted signal is your decay and minus is your received signal at the receiver side or the detected symbol. Okay. So why are we doing transmitting minus receiving? Because during reception, it is very obvious that the amplitude of the signal after passing through a long distance of this wireless propagation channel, the power is there is path loss or there is power loss at the receiver side. So the amplitude of the received signal will always be less compared to your transmitted signal. So here we are actually doing the error calculation as transmitted symbol minus the detected symbol. Detected means what is it is receiving at the receiver side. So instead of getting a transmitted signal 1, we are receiving a 0. So error would be 1 minus 0, which is 1. So error is almost equal to 1 here. Okay. Now my objective of MMSE equalizer or minimum mean square error equalizer is not just to overcome this ISI. Every equalizer wants to overcome ISI, but so zero forcing is only focusing on removal of ISI. But MMSE equalizer is one step ahead of zero forcing equalizer. How it is performing better? It is focusing not only on this ISI but on the overall error in the received signal with the transmitted signal. So it will calculate the error between the detected symbol and the transmitted symbol, and it will try to minimize this error. Minimize means make it as small as possible by reversing the characteristics. So it will optimize its weights, it will optimize the multiplication factor at the receiver side so that we can minimize this error between the transmitted symbol and the detected or the received symbol. And this error minimizes means the transmitted symbol is almost equivalent to what we are receiving at the receiver side. So we're trying to remove this error between this transmitted and the received signal here. Okay. How we are going to minimize? We are going to first calculate the error between the two. That means the difference between the two. Then we are going to calculate the square of this error and then calculate the mean of this error. So we are doing this in a two-step format. First, we are going to do the square of the error, then we are going to calculate the mean of the error, and finally, we are going to make this whole factor, minimize the whole factor here. So, here, we are not just focusing on the error factor, we are focusing on taking the square of this and calculating the mean of this. So, you will find the average of this and take a square of this error and minimize this as much as possible. So when I'm minimizing this error here, what am I focusing on? I am focusing on not only reducing the ISI, but I'm also focusing on reducing the noise factor in your received signal. Okay. So when I'm focusing on reducing the noise factor at the receiver signal along with ISI, this equalizer automatically overpowers your zero forcing equalizer. So it is more advantageous compared to your zero forcing equalizer. Clear? So what is the objective of MMSE equalizer is to minimize the average square error between the transmitted signal and the received signal. That means what is the factor that we are focusing on? We are focusing on the function of the error, which is the mean square error. So what is this error? Error is the difference between the transmitted signal and the detected signal. So if I compare your MMSE equalizer with zero forcing equalizer only focuses on ISI itself. It does not focus on the noise factor. But MMSE equalizer, it does not focus only on the ISI or the noise. What it is focusing on? It is focusing on the actual error. Okay, the actual error or the difference between transmitted and the received signal. It will try to calculate that error, take a square and the mean value of this error function, and make the changes or optimize its multiplication factors in such a way that this error can be minimized as or made as small as possible. So ultimately, what is this effect of making this error small as possible? It is actually reducing both the effect of the ISI due to the multipath effect of the channel, as well as the noise factor which is introduced in the signal during the wireless propagation. Okay, so this is the basic comparison of the two types of linear equalizer, that is your zero forcing and your